Wait.
The purpose of this summer camp in our team is to help our students gain interest and confidence in scientific research.
We spent the first few weeks of camp reading research papers on superhydrophobicity and blood repellency. At first, it was challenging to comprehend the research papers, but as time progressed, the task became easier and easier under the guidance of our graduate students. We discussed and presented our findings to one another, expanding our understanding of the topic.
We noticed that many of our research papers referenced a common point of inspiration, lotus leaves. In order to observe this intriguing phenomenon in nature, we decided to wake up bright and early Saturday morning to take a trip to Grace's Lotus Garden.
The lotus flowers were beautiful, and as expected, the water droplets effortlessly bounced off the surface of the lotus leaves and left it looking as if there was never water on it. We also observed its self-cleaning effect as the water easily washed away all the dirty particles on its surface.
Hi! We're at Waffle House right now. We just came back from the Lotus Garden. Yeah. After studying superhydrophobicity.
Totally!
Back in the lab. See you!
After reading up on the topic and observing it in real life, we were ready to begin our lab. Our project was to create a blood-repellent gauze to solve the problems of current state-of-the-art bandages, including possible infection, lack of evaporation, and adhesion to the wound.
While initially a few of the tests were unsuccessful, we utilized our knowledge regarding hierarchical structures to eventually develop a superhydrophobic gauze that met all of the criteria. After having success with water, we dropped sheep blood onto our treated gauze to determine if it would have the ability to repel blood as well. It worked.
To be 100% sure it was superhydrophobic, we took our gauzes to the goniometer, a scientific instrument that measures the contact angles of droplets, allowing us to analyze the effectiveness of the coating.
After confirming that our gauze was truly super hydrophobic, we were finally able to go down to the SEM room to observe the hierarchical structures of the coated gauze.
The SEM, or the scanning electron microscope, which displays the size of the tiniest micrometers, enables us to clearly see the micro and nanostructures on the surface of the coated gauze as opposed to the smooth surface of the uncoated gauze.
Besides the technical aspect of this camp, we had weekly Friday lunches with the whole camp and socialized with other groups. The seminars were very intriguing, and we learned a lot from the invited speakers.
Not only has this camp increased our confidence in research and showed us that the process is not as difficult as we believed, we have also made quite a few lifelong friends. Our group quickly bonded through our love of science and research and made many fun memories together that we will never forget.
Thank you so much to UTD and CASTEM for this wonderful experience.